Good morning, colleagues, ladies and gentlemen. Welcome to the second day of Enhanced River Basin Monitoring System for Improved Collaborative Water Resources Management and Development. Yesterday, we've been talking about the value added, the features, attributes, essential components, basic requirements. What are the essential elements for a comprehensive river basin monitoring system? Indeed, there is international standards that cover all the elements and components of a modern river basin monitoring system. So yesterday, we've been discussing what are the design elements, what are the components, how to meet the international standards. And indeed, there is international standards for each and every single component, including the sustainability issues and the capacity development and standard operational procedures. There are manual, there are Wmo standards in terms of the coverage and the location of station and spatial distribution. But because some of the sites will be inaccessible in remote areas or due to security or transportation limitation, we will have to combine ground observation with earth observation. And here comes the other techniques under remote sensing and the like. Those remote sensing techniques complement the earth observation part in order to have an integrated river basin monitoring system. So today, we will be talking about this kind of linkage and how to integrate them together in order to have a complete portray, a complete knowledge on the information. However, everything has pros and cons, advantages and disadvantages. So we will talk about the techniques, the accuracy, the reliability, how to best strike the balance between earth observation and hydrometeorological physical networks and earth observation and remote sensing technique. I would like to invite Engineer Russell Bowles to start giving his keynote. Engineer Bowles is a senior water resource specialist, has over 35 years of project and program management experience with both government and international organizations, as well as the private sector. His international experience covers hydrometeorological monitoring, water resources management, water sharing, and institutional strengthening within the context of integrated water resources management, climate and disaster resilience, flood and drought, and he has an extensive experience in several river basins like Mekong River, Zambezi River, and other major river basins, including the Nile. So I will give the floor to Engineer Russell Bowles to talk about the state-of-the-art technology in river basin monitoring and how to integrate, how to complement Earth observations and ground stations. Engineer Bowles, the floor is yours.
Dr. Mosen, thank you very much for that kind introduction. I assume everyone can hear me, and I assume that you can see the slides. Can someone confirm that, please?
Yes, Russell, we can hear you.
Okay, thank you. I want to thank you for the invitation to this forum. I think it's a very important forum to have this conversation for the Nile Basin, and I'm really pleased given the opportunity to provide a perspective on state-of-the-art technologies for river basin monitoring. I think it's important to understand and to use these state-of-the-art technologies appropriately. My presentation is going to introduce you and give you an overview of the state-of-the-art technologies and provide a perspective on these technologies and how they can be used, how they contribute, and some of the things and issues and challenges that you have to consider when you use and implement these technologies. There are a few other presentations that will be presented today that will actually demonstrate a particular technology and how it can contribute to the regional basin monitoring activities in the Nile Basin. So they will, I'm looking forward to hearing from them because I think they demonstrate very clearly how these technologies can be incorporated. I think it's important to think about the questions that we're trying to address in this session. There's really two types of questions from a technology perspective that we've been asked to look at. Is how can we achieve a comprehensive monitoring system using these state-of-the-art monitoring technologies, which tends to be more focused on the data and information generation piece. If you attended the session yesterday on this, Engineer Mark Woodbury and a number of others talked extensively at the importance of data and information, and a number of the conversations we had were around that subject. The other how can question that's being asked of the technologies is how can these technologies support informed basin planning as well as sound development in the Nile Basin? And this question speaks more to the service delivery and the value added perspective of these technologies. So we're looking at using these technologies not only to provide additional data and information for the Nile Basin, but we're also looking at these technologies from the perspective of providing information and services, value-added products. And what I'd like to introduce when we think of technologies is this is only one dimension of a monitoring perspective. The technology is only one dimension of that particular perspective. You need to consider not only the technology aspect, which we will certainly talk more about during this session, but you also need to consider the institutional implications of employing this technology and deploying it. And we also have to think about the other dimension of what services and value added to these technologies bring. So the important message that I'm going to emphasize through this presentation is to be able to address and use these technologies and gain the advantage of these technologies. It really requires proper deployment. That's the key message throughout this presentation, is to ensure proper deployment of the technologies. So I'm giving you the key message right at the beginning, and through the various slides that I'll be presenting is I hope to emphasize what proper deployment of these technologies considers and what it means. Some of the other key messages and series that support that proper deployment that we'll be talking about is the purpose of using technologies and deploying these technologies, which are really information and service driven. And we heard a lot about that yesterday and the importance of it and how it adds to the sustainability and the direction of a monitoring program. However, I want to present the challenge of big data and talk a little bit about it during this presentation. I want to talk a little bit about the technology interface challenges so that we think about these and be aware of them. As already mentioned, the institutional dimension that we need to think about, just to highlight some of the things that have to be considered to ensure there is proper deployment of these technologies. When we start to think about service delivery, we need to consider the levering of these technologies to be able to not only improve the service delivery and the products and timeliness of the services that we provide, but also how these technologies help us run a more efficient monitoring program, as well as how do you integrate ground-based technologies and consider remote sense and space-based type of technologies to complement the ability to produce information and services. And of course, the sustainability question comes up on a number of occasions. The perspective that I have on state-of-the-art technologies is you need to think about it as a system of systems for gathering data, information, and services. And so each of the technologies themselves are a system, but the key is how do you bring them together into a complete system? How do you bring each of these individual systems together in a complete system that effectively generates data, information, and ultimately provides the services that are required? So it's more than just talking about what widget should I use or what is the best widget that's out there. It's a multi-dimensional focus that needs to be taken to ensure that you have proper deployment of these technologies, the technologies that you select, and to be able to generate the services and information that you expect from our regional basin monitoring program. The next slide I'm showing, it's a picture of all the various technologies that are available to us to do basin monitoring. And I've borrowed this image from a WMO publication that was dated in 2018. And the technology is changing so quickly and new advances. There are technologies that are incorporated in this 2018 diagram, such as drones are being used extensively now to do monitoring of systems. And so they're missing from this. The satellites that are showing in this for the space-based monitoring are only a few of the significant number of satellites that have been and are currently been launched. There's a whole series of what they're calling small cube satellites that are being launched, not only for improving internet and communications capabilities, but also to improve space-based observations of the Earth's surface, to do measurements of the Earth's surface and the various features on it. As well as you'll note that this diagram tends to look at the National Meteorological Service side, but you can readily think of a hydrometric gauging station in this diagram that looks very similar to monitoring a river. The other aspect that's missing from this diagram is the ability, the communications, remote communications, tends to be from the field site to the office, and it's lacking the communications dimension that's currently available and very powerful to use, is actually communications from the field site to a geostationary satellite and or the polar orbiting satellites. The geostationary satellites provide an advantage for these ground to satellite back to a receiving site at the home office for data in real time. In this case, the geostationary satellite that's very important for the Nile Basin is one operated by the European Space Agency, EUMETSAT, and it offers really good not only image coverage of the Nile Basin, but also provides a data relay capability so that you can transmit from your field site to the satellite, receive the data back in your office, and basically this time in hourly transmissions of the system. The interesting part about this, if you look at the growth in technology, if you looked at this diagram in 1990, there'd be much less information on it. There'd be a few ground observing sites. There'd be some way communicating to the office. In a lot of cases, there was very limited communications. If you move to 2020, then you start to see more of the real-time communications, more of the automation, more of the use of satellites. So this technology space is really, really getting filled, and it's getting filled at a much quicker rate each year. So all these technologies, when you think about river basin monitoring, you have to think about how do I lever or take advantage of these technologies that are available to me to do the monitoring that's required to provide the services and information for the basin. And I think it's important that we heard yesterday about Hydro SOS. And if you think about Hydro SOS, what it's trying to do is take advantage of all these technologies for providing data and information, integrating that to be able to provide a service, a decision support system, to be able to support better information that's integrated. And I think that's one of the goals that we should be looking at when we're trying to deploy state-of-the-art technologies in the Nile Basin. The next slide speaks to a slightly different perspective on which Engineer Mark Woodbury presented yesterday, but it's very, very similar. At this end, Mark talked about a chain where we talked about data moving to information, moving to knowledge, which basically supported decision-making, which had impacts. And you can see the similar approach in this information value chain, except this diagram looks at it from a more technology perspective, but it still has the features of decisions and impact. It still has the features of knowledge and information, and it still has the features of data. What it allows you to do is look at each of the discrete parts of the technology piece and how technology can be used for observations. It also points out the data management piece has to be considered from a technology perspective as well. You have to consider your analytics and modeling piece from the technology perspective, as well as the technologies for service delivery. So it's much more when you talk about deploying state-of-the-art technologies and just thinking about how do I collect data. You need to be thinking about not only the data collection piece, but how do I manage that data and quality control? How do I do the analytics on it to produce information and understand trends and volumes? And how do I package it and provide that in a manner that decision makers, clients, and users can take advantage of it to make appropriate decisions in the basin. So we need to be thinking about technology from all these complete aspects of it. So the next slide, I just want to walk through some concepts over the next slide. One is fit for purpose. And what does this mean? It means to make sure you choose the right technology for the need that you have. In this case, as an example would be, if I'm a fisher person on a river and I know that at certain stages of the river that I can easily transport my boat and go to a fishing area because of the water is high enough that I can move over a rock reef or so in the system. For that individual, the fit for purpose technology is not sophisticated. They need to know if the water level is at a certain elevation, that it's safe to be able to transport over this reef, or they need to know if it's at an elevation that may be too high and dangerous. So it's a very simple piece of technology that they need to address their concern. It can just be a particular measuring point, a rock or so that tells them based on their historical knowledge and understanding. Yes, it's safe to go on the river today, and yes, it's safe to go on the river and I can be able to reach my fishing spot. So that's what fit for purpose means, is to make sure you choose the appropriate technologies that meets the particular questions and purposes that you want to use it for. Now, in the case of a river basin monitoring program, and this was emphasized very clearly yesterday in Mark Woodbury's presentation, is we're really looking at the purpose is long-term records. We need long-term records. They need to be reliable. They need to be comprehensive. They need to be comparable. They need to be accurate. And so the type of technologies that you choose for your regional monitoring program, given those needs, must be able to produce data and information that meets those characteristics. So what does this mean when you're thinking of these technologies? And the technologies that are available to us today to meet those purposes of our regional monitoring program is we're looking at smart sensors. And these smart sensors are really available in a number of configurations. And what we mean by smart sensors, there's actually a microchip embedded in the sensor, and I'm talking about in situ sensors, so this is for ground-based monitoring, that actually calibrates, checks the performance of the sensor itself, adjusts for other parameters such as temperature, salinity of water, etc. But they're also a smart sensor in the sense that it minimizes the power requirement for the sensor. When it's not in a sampling mode, it actually shuts itself down and goes into a sleep mode. So it minimizes the power requirement, which has an implication for the way you power your field station and the amount of power that's required, both in the sizing of the solar panel and the battery itself. But these smart sensors are very efficient sensors to use. They have a long life. Their calibration needs are much less because they do corrections for drift in the sensor. And they're also smart enough to tell you when they're out of calibration that they will send an alert message or a message to you that I need calibration. So they really help you in deploying and maintaining those sensors and providing good quality data. The other aspect that we're trying to do with these technologies, and these technologies allow us to do, is minimize the environmental footprint of the field systems themselves. Because we can use smaller power, because the electronics and everything are much smaller, We can put them on a tower within an enclosure, and so they don't require major infrastructure. One of the key things of the technologies for fit for purpose is communications, which is really the major advancement that's occurred over the last 10 to 15 years, is the ability to have near real-time data from your field site in a fairly cost-effective, robust manner. And I would just like to promote the Nile Basin with the EUMETSAT services that are available, and being WMO member countries, as this service is actually available free to you for hydromet services in the basin. It's supported by WMO. When we talk about a regional monitoring program, we certainly have to look at WMO standards and guidelines. The message here is price is directly correlated to service life. Often when we look at technologies, there is a desire to maximize the budget that we have available and buy as much equipment as we can. However, it's sort of a false investment, because in the modern technologies that we're using for the type of work that we do in environmental monitoring, the price is directly correlated to the service life of the technology. So the less you pay for it, the shorter the service life, the more calibration that's required, as well as the replacement cycle will be much higher. So when we look at a regional monitoring program, we do look at very high quality instrumentation, because it will have a long service life and have a limited ongoing operating costs associated with it, as well as produce good quality data for an extended period. So that's the other aspect. The message here is we really need to be thinking about not only field-based and space-based, and not only field-based type of monitoring, but we need to look at how do we integrate space-based systems into our monitoring program. And so it's not looking at space-based remote sensing as an alternative, it's how do you take advantage of those space-based systems, whether they be drones, aircraft, or satellites, is how do you take advantage of them. But there is a key consideration, there's a big data challenge as you automate not only the field-based systems, but the space-based systems. And if, for example, if you look at using technology and you sample every 10 minutes and you have 5 parameters that you're sampling, such as water level, with the technologies that we use today, you can get water temperature. If you have battery voltage, you have a preset gauge, you have another station health characteristic, such as moisture in the data logger, etc. Is you can quickly, over 1 year for one station, is generate 250,000 data points. And I think you'll recall, Mark Woodbury did a calculation yesterday where if you had one reading per day, for 20 years, it would generate roughly 8,000 data points. And so the point here is technology quickly generates big data that you have to manage and handle just from your field station. The space-based data sets can be gigabytes per day that you have to manage. So what does this mean? This means that when you deploy this type of technologies, you really need to think about your data management and the analytical approach that not only supports the management of this particular data, but the quality control and archiving and processing of it, but also the analytics that's required to convert this data into information. And so it includes software and systems that will generate products, will do modeling for you. Certainly GIS for visualization and the analytical part offers a significant advantage. In this technology area, there's a number of commercial off-the-shelf data management systems. There's also a number of vendor-specific systems that are available. The challenge here is there's an ongoing license cost for most of these that we have to consider when we deploy these technologies. Another advancement that's offering opportunities for us is on-premise versus cloud-based approaches. And there's advantages and disadvantages of both. And we can have a significant discussion over an extended period of time on both these. I just want to bring it to your attention. But the cloud-based options can be for hardware-only support, so you just have access to hardware. They can be hardware and systems applications, such as database systems, standard database systems, standard GIS, or they can actually extend to your full service type applications, where you have particular applications that actually process data and generate information through statistical applications, which are available through a cloud-based type of operation. One of the items I want to draw to people's attention is the challenge with implementing these technologies is not in the individual systems themselves, such as the field system, the data management system, the modeling or GIS system. It's where these systems interface is where the challenge becomes and where you have to put your effort. So the field technologies need to seamlessly interface with the data management system. And you would think this would be fairly straightforward, but if you think about different equipment from different vendors providing different formats, communicating in different means, it becomes a very complex and a very quick manner, especially when you consider the amount of data that's being transferred. Of course, and this your data management system has to interface easily and efficiently with your analytical modeling platforms, as well as interface with your information and service delivery platforms. So the concept here is we need to be thinking about deploying these technologies in an end-to-end type of systems approach if we want to be able to gain the benefits of these technologies. The other aspect of this that's often overlooked is implementing technologies in your organization does require a change management need. It's not a matter of implementing the technology and nothing will change. You need to consider the implications that the technology will have on your organizational structure, the type of skills that will be required in your organization, the budget implications, both the operating and of course, as you use technologies, at some time it wears out, you need to be thinking about, so how do I replace that? And what budget will be required to do it? You will need new standard operating procedures to be able to manage, ensure the quality of that data. And you'll need to think about how you move from a data service type of operations, providing data, to one that looks at providing information and value-added services. So the message from the institutional change side is you really need to rethink your business model or evaluate your business model to see if it's appropriate to take advantage of these new technologies if you're going to be able to lever the benefit that they have. We talked about levering technologies. And I think it's key, my key message here is that we need to move from a data-focused type of organization where we're just producing data to being an organization that is more responsive and actually focus on the information and the value-added services type of organization and use the technologies to help you. Use the technologies to lever this big data that you're gathering either from the ground-based stations that's available to you through the space-based type of technologies and the real-time advantage that these technologies offer you, as well as the increased capabilities, analytic and modeling advantage to all build your information and service opportunities. And if you recall yesterday when Mark Whitbury was talking about sustainability, he noted some of the key influencers in sustainability were related to decision-making, services, and meeting client and user needs. So this links very directly, these technologies link very directly to providing you the ability to be in the service and information space of an organization. The little note here is it's really interesting. You need to watch, you just need to watch the Internet of Things, because there's so many new applications that are coming available through the internet that actually you can lever and download and use to help you with your data processing or some of the service delivery side. And the other aspect here is you need to engage with your user clients and decision makers on a regular basis. It's more, if you want to gain from this technology, it offers you a number of advantages, but now you have to talk and be engaged with the user community, your clients, and the decision makers to let them know what features and what you can do based on the technologies that you have. There's one little concept I want to highlight here is we often hear about quality and value added. And it's really interesting to note that when we talk about quality of data and products, this is an internal perspective of the organization. And often this is what we focus most on, is trying to produce quality data and products. And we never think about the value added services, but the value added services are external perspective. It's the users, clients, and decision makers that have this value added, that realize the value added of your services. And these are the people that are going to assist you, this user community, this client community, the decision makers, in sustaining your data programs and producing good quality data and products. From a sustainability, I think you've seen throughout the presentation is some various hints at this. Certainly budgets are important, but they're not the only consideration. We talked about fit for purpose, so we have to choose the right technologies to fit the information and service purpose that our mandate provides with what we're trying to accomplish. We need to consider the complete system from the service prevention, information generation, to the data analytics and modeling, and to the data source, and look at how we lever the on-ground base stations as well as the space-based stations to the maximum advantage. Of course, sustainability needs to consider the institutional modernization, which will include new policies, structures, and new skills. So rethinking the investment in the Nile Basin from a technology perspective, I think it's important when we think about investments in Nile Basin, is that as a Nile Basin community we need to think about collaboration on monitoring technologies and systems, to look at how we can develop a common standard within the Nile Basin. We need to focus on the data management and information generation side and learn from one another and lever off of one another. We certainly have to take advantage of greater use of the space-based Earth observing products and services, not as an alternative, but as part of the solution to providing information and value-added products. And the emphasis may be on a few well-performing ground stations, and then other than a lot of poorly performing ground stations. And because if you think about the integration and the space-based observing techniques, they really require representative information, good quality, real-time representative information from a few well-performing ground stations to improve their space-based algorithms and the products and services that they can produce. So in summary, the message comes back to not which technology we should use, but the proper deployment of all the technologies that are available, to the proper deployment, the proper selection of the technologies that are available to us. And I believe that it will certainly deepen the Nile Basin cooperation and certainly will advance informed basin-wide planning and sound development. that brings me to the conclusion of my presentation. And thank you very much again for the opportunity and look forward to your questions. Over to you, Wilson.
Thank you very much indeed, Engineer Russell. This was a very comprehensive coverage of the technologies and how to strike the balance. And it is very clear now that everybody knows that fit-to-purpose technology is the best way. And we have to move from the data-based organization to information-based. And we think about all the elements, including the technology, the cost, and overwhelming data side. This is very insightful to everybody. However, please stay with us. There will be some questions. I don't see any questions right now, but according to the program, we will be moving straight to the second presenter. So allow me to invite Mr. Fitsumi Choma Wilkibida from Ethiopia. He will give us an example of what Engineer Bowles was talking about a few minutes ago. He will talk about using remote sensing data to estimate water inflows and water balance of Lake Turner as an application of remote sensing for integrated monitoring and management of large water body systems within the Nile Basin, and the case study or the demonstration of the approach is on Lake Turner, Ethiopia. Mr. Fitsumi, the floor is yours.
Okay, thank you, Dr. Mashal. Is my voice audible?
Yes, we can hear you well.
Okay, I hope my screen is visible.
Yes, it is visible and you are audible, and please proceed. Everything is okay.
Okay, thank you, Dr. Moshan. So my presentation is going to be a specific case study of Lake Tana, but with an indication of using or water level monitoring. So it's specific to Lake Tana and specific to water level monitoring using remotely sensed data. So as this has been already discussed by the previous presenters, we need data to monitor our water, and data is available in different formats, and
seem to have lost Fitsume. Fitsume, are you there?
So it seems like Mr. Choma had a network interruption. While waiting for him, we had an equivalent hydrological evaluation based on satellite-based rainfall.
Yes, yes. Hello, hello.
Ah, you're back.
Oh, it was not audible.
No, you were disconnected all of a sudden. So can you please proceed now?
Oh,
We thought it's an internet
sure,
interruption.
yes.
Okay, please proceed.
Oh, okay. So we managed to collect data for Lake Tana from 1993 to 2013, both the observed and the remotely sensed data.
Please
And
screen share.
since we
Share your screen again.
Mr. Fichomi, your screen is not visible. And make it bigger, please.
okay, how about now?
Yeah, but make it in a slideshow mode.
Okay, how about now? Is it okay?
Just start the slideshow,
Is it
resume
visible
the
now?
slide. Yes, 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 yes. Perfect. Thank you.
All right. Okay, just to recap, if I've missed in the network connection, our case study focused on Lake Tana, and it compared the observed water level data of Lake Tana with the remotely sensed from satellite data, and it tried to bias correct, as it has been discussed in the previous presentation. Since the remotely sensed data had some bias, we had made some bias correction to further improve the remotely sensed data. What we found is initially the initial estimation of the remotely sensed data was not actually that bad. So the data interval was different. The observed data was daily, but the collected satellite data was decadal. So there was some difference between the intervals. So we have aggregated the observed data to the decadal. So this is one of the results. We classified the remotely observed data based on the emissions. So for the observed data that we had 3 missions: TOPEX mission, JSON1, and JSON2 missions. So we tried to estimate the bulk error in the missions and distribute it over the assumptions of the satellite for the given period. For example, for the JSON 1 from 2000 to 2008, what we did was we collected the average error and distributed it over the year. Similarly for the TOPEX also, and also for the JSON2. So the blue one that is visible is the raw data that was collected. And the black one, those are the dots where they observed. There was some variation. And after bias correction, the resulted hydrograph or the resulted water level data was the red one. So the bias correction, or distributing the lump error over the period of the mission, has reduced the error significantly. As it can be seen, the TOPEX has had some bias, which is greater than what we found from the JSON1 and JSON2 missions. And the bias correction, or distributing the bulk bias over the period of the mission, has significantly improved the data. So statistically, we have compiled the statistical comparison of the data sets for each specific mission. So for the topics Poseidon, the before correction and after correction, the root mean square, the Neistat cliff, and the percent bias were computed. As I have said earlier, this was the initial mission, so it had reports that it has some bias in estimating water level, especially when the area becomes very small, like the Lake Tana. It is reported also to be working good in areas with larger area for oceans and larger reservoir areas. So in the capturing the trend, the adjustment didn't improve that much, but in capturing the peaks, as can be seen in the elevation plots, in capturing the peaks, the bias adjustment has made some improvements, but the trend or the seasonality, the seasonal change has been captured in a very good way by the missions. Also in the bias of volume or the volume bias in estimation is significantly improved. So this was what we did on the raw data that we have managed to collect on Lake Tana. As I have said, the raw data by itself without improvement on a decadal time step, it had a very good, especially JSON 1 and JSON 2, initially had good estimation, but TOPEX had some smaller estimation, especially it had limitations in finding the peaks or the larger values. So this is the result that we have found. So on the TOPEX Poseidon, the bias is significantly reduced. JSON 1, JSON 2, it is improved. So after that, what we did was, can we get other data for other reservoirs in the Nile Basin? That is what we checked. Yes, we have found some data for Rosaries in Sudan, for Lake Nasser in Egypt, and for Lake Victoria also. So these were available from the satellite mission. And this was not bias corrected, but the data is available. As I have said earlier, the two missions give really good data, but we need to check for this specific reservoirs. So after the bias correct data to estimate the inflow into Lake Tana from the engaged catchments, because there we have engaged catchments around Lake Tana, and we only have these gauging stations around Lake Tana. So what we have found is encouraging. We used totally the bias corrected remotely sensed water level data of Lake Tana, and what we have found is about 1,000 million cubic meter per year. We compared it with other studies. It has some variation, but that was not significant. And this is just as a case study that we can use the bias corrected remotely sensed water level data in hydrological models of reservoirs. So from this, what can be taken is remotely sensed data can be used as an alternative to monitor large lakes in the Nile Basin, because we have natural and artificial lakes in the Nile Basin. So remotely sensed data can help on monitoring this data for water resource development. This study also revealed that the remotely sensed data, now we specifically used altimeter data, can be used as an input to hydrological models to estimate inflows or flows in ungauged catchments. But we have also these limitations. We used one type of remotely sensed data, that is altimeter data, and we used it in a decadal time step, It's that the result is not on a daily basis. Also, the quality can be improved further by employing other type of bias correction methods. Our bias correction method is distributing the error for the mission period. So this is what we can take from this, and further research can be conducted on specific reservoirs in the Nile basins for better results and for better utilization of remotely sensed data. So this is in short what we have done, and an indication of using remotely sensed data in monitoring reservoirs in the basin, and also in using remotely sensed data for hydrological modeling of reservoirs. Thank you very much for your time. I'll give the floor to Dr. Moshe.
Thank you very much, Atu Fichoma. This was an example of what Engineer Russell Bowles has been talking about, of having to strike a balance between the cost, the technology, and how to employ remote sensing to get the information that is costly or extensive to get to ground stations. We have a second presentation before we go to questions and answers. I hope that we have Dr. Mohammed Hassan from Sudan. He will tell us about the hydrological evaluation of satellite-based rainfall data sets for transboundary water resources management in data-scarce region. And the application case will be Tikezi Atbara, Dender, and Blue Nile River sub-basins. Dr. Mohammed, the floor is yours. You have 15 minutes, please.
Thank you, Dr. Mohsin. Can you hear me?
Yes, we can hear you. Please proceed.
Okay. First of all, I didn't have the title doctor, and thank you for that. Morning, everyone. I hope you are staying safe during the current pandemic situation. First of all, I'm thrilled to be here with you in this valuable webinar series of the 6th Nile Basin Development Forum, and I hope this webinar series will be enjoyable, fruitful, helpful, and informative. My name is Muhammad Adil Hassan, and I'm here to present this presentation entitled Hydrological Evaluation of Satellite-Based Rainfall Datasets for Transboundary Water Resources Management in the Data-Scarce Regions. And the case study for this paper is Tikezi Atbara Basin and Dender Basin and Blue Nile River Basins. And this paper authored by me and also my son Usman, Balaf Komar, Luis Saminego, and Abdurrahman Saghairun Zain. Let me get started. Is my screen visible for you?
No, you have not shared your screen yet.
Try to share my screen.
Yes.
Is it visible now?
Yes, just
okay.
Make it in a slideshow.
Okay, I will. Here is a little background about the problem statement and the research objectives of this study. And as you know, the transboundary water resources management in our regions, I mean in data scarcity regions, such as the case study, or such as the study area, Blue Nile, Dinder, and Tekesi Atbara, is very complicated since updated data at fine temporal and spatial resolution is lacking, and yet there is no agreements or protocols for data sharing across the political boundaries for transboundary river, for transboundary water resources management. Therefore, reliable rainfall and stream flow data is very important and crucial for water resources management and as well as for various hydrological applications, as you know. And due to these reasons, we have to find other alternatives sources for this data. I mean, for rainfall and stream flow. And for rainfall data, I think satellite-based rainfall products are increasingly becoming an essential and alternative source for rainfall data. It can offer rainfall data sets at high spatial and temporal resolution, and it potentially supporting management and assessing water resources applications in these regions. I mean engaged regions or data scarce regions. But there is important notice, this kind of data sets needs to be validated as their accuracy and reliability varies from basin to basin and from topography to topography, as well as from calculation algorithms to another calculation algorithm. I mean the type of satellite itself. Also, the hydrological modeling can play a vital role in water resources assessment for generating stream flow data. The objectives of this study is to hydrologically evaluate the capability of widely used 10 different satellite-based rainfall datasets to drive a hydrological model at different temporal and basin scales. By temporal, I mean at daily and monthly time steps, and for basin scales, I mean we have in this study a big basins and medium basins and relatively small basins, especially small basins. And then ultimately to hydrologically identify which dataset product has the best performance and the best fit along the three basins by comparing simulated flows to observed flows in the ground. And this slide, we are going to talk about the study area. This is the study area. We have here the Tekesi Atbara Basin. And here we have the Blue Nile Basin, and here we have the Dinder Basin. For the Blue Nile, the Blue Nile is one of the most important river for the River Nile because it contributes about 60% of the River Nile flow, and its transboundary river basin, which is located in Sudan and Ethiopia, as shown in this figure. It has high variability and seasonality, and complex topography, and it has originated from Lake Tana at a height about nearly 4,000 meters and ends at Khartoum at heights of 300 meters, I think. This basin evaluated in this study at Dam Station. As you know, this is Dam Station at the Sudanese-Ethiopian border. The second one is Tekezi Atbara. Tekezi Atbara is also a transboundary river, which is located in 3 countries, Ethiopia, Eritrea, and Sudan. It contributes about 40% of the Nile water. In Sudan, it has 2 main tributaries, Sitet and Atbarawi rivers. And in this study, we were used the Kobor station to evaluate the simulations from Atbarawi river. Kobor has seasonal character. I mean, most of the time the river is dry. And the third one is the Dender River Basin. It is the largest tributary of the Blue Nile in Sudan, and it originates from the Ethiopian plateau west of Lake Tana, and it has seasonal character also. And in this study, the Dender evaluated using Gwesi station somewhere near the basin outlet here, as you can see. The next slide is the methodology and approach of this study. Actually, in this context, as I mentioned before, I think in the previous slide, it has been demonstrated that hydrological models can be a valuable tool, and it can provide a common platform for experts, decision makers, and professionals, and so on. And there are many types of hydrological models. In this study, we will use a distributed, fully distributed grid-based hydrological model, which is called mesoscale hydrological model, MHM. And in this study, the MHM was applied to quantify and simulate the runoff and water availability of these transboundary river basins in case study. This model developed by the UFZ Institute in Germany. They are co-authors in this paper, Lewis Samanigo and Balaf Komar Shrestha. And the initial conditions and parameters of the model are obtained using spatially disaggregated ERA 5 reanalysis data and optimization functions that built in MHM. Here are the inputs here. The main inputs for the model is the satellite rainfall and potential evapotranspiration data, and the level 0 data, I mean the terrain data, like digital elevation model, soil and land use, land cover, and so on. And then the processing will done with the MHM After that, we need to calibrate and evaluate the results. And finally, we will have a stream flow, calibrated stream flow. Also calibrated parameters here. For the evaluation, the model evaluated using 4 different evaluation statistics measures. The KGE, I mean the Kelling-Gupta efficiency, and the NSE, and the R squared, and the percent bias. We have used this for evaluation statistics to evaluate the results of the model. And here we have the data sets and materials. Here are the satellite data sets were used in this study. Here we have used 10 different satellite-based rainfall data sets. And we have used one data set for the potential evapotranspiration calculations. This data set called WATCH. And the data sets are ERA 5, number 1, and CHIRPS version 2, and RFE version 2 from NOAA, and ARC, African Rainfall Estimates Climatology, version 2, and TAMSAT 3, and TRMM version 7, and CMORPH, and GBM iMerge data, and WATCH, and Persian CDR, Persian Climate Data Record. And this is the spatial resolution and temporal resolution of these data sets. And also the products were selected based on the widely used and public domain. This data is publicly accessible. And the second criteria is long-term data availability for the calibration and validation purposes. And the third one is reasonable spatio-temporal resolution, and so on. This is the criteria that used to select these 10 satellite-based rainfall datasets. And the second one is the terrain data, level 0 data sets we have used for the MHM, the DEM, and soil and land cover, and so on. This is the data we have used for the terrain. This is the level 0 data for the MHM model. And here we go. Here are the results from the hydrological model for the 3 basins. First is the results of the Blue Nile Basin over the 10 satellite rainfall datasets. I hope so. I hope so. They are clear to you, and I hope you can see them easily and vividly. I had to put them on one slide because they asked for the limited number of slides, and they tell us that the number of slides should not be exceeded and 12 slides. I hope so. You can see them clearly. This is the calibration period for 5 different data sets, and here also the calibration and validation period for other 5 different data sets. Here, number 1 The upper left is chirps, and this is the performance of chirps. And next is the performance of ARC2, and next is CMORPH, TRMM, TAMSAT, here GBM and ERA5 dataset, WATCH dataset, and RFE2 and Persian dataset. Don't worry, we will summarize these figures in the next slides. Actually, I try to be concise as much as I can. The next one is the results from the Tekesi Atbara Basin at Kokur Station. As you can see, here are the results of Kokur station at daily time step. This is the calibration period, and this is the validation period for whole 10 data sets. And here, the Dended Basin results at El Guesi station. Also, for the whole 10 data sets. And here is a summary of the results for the 3 basins on daily and monthly basis. As you can see, for the Blue Nile Basin, this is for Blue Nile Basin at Dame Station. All the 10 data sets achieved good to excellent hydrological performance over the Blue Nile Basin. You can see here the values of NSE, KGE, R squared, and percent bias for daily time step calibration and validation periods. Also for monthly time steps calibration and validation periods. The NSE for the Blue Nile Basin ranged from 0.77 to 92.92 for both calibration and validation periods. While KGE ranged from 0.75 to 0.95, and also the percent bias achieved acceptable values. The monthly values showed an excellent performance for the Blue Nile Basin for the whole 10 different data sets, and it achieved 0.82 and higher. 0.82 and higher of NSE and KGE for both calibration and validation periods. Next is a summary of Kokur for Tekesi Atbara Basin. As you can see here from these figures, I can say all data sets, all 10 data sets achieved good to excellent hydrological performance, except Persian CDR. You can see here, you can see the value of NSE for Persian CDR is 0.31, which is poor performance. And for the whole data sets, the NSE, except the Persian data set, ranged from 0.56 to 86 for both calibration and validation periods. And also the KGE achieved good to excellent performance, and so on. The monthly values showed good also to excellent performance for the Tekesi Atbara Basin. And last is the summary of the Al-Guwaisi station for the Dindi River Basin. And at daily time step, the model achieved fair to good, fair or acceptable to good results, except ERA 5 and RFE2 and ARC2, which achieved poor performance, as you can see here. ERA 5, ARC2, and RFE2. While the other data sets achieved acceptable to good performance, and the monthly time step also achieved acceptable to good performance. And and here we are, the conclusions and recommendations of this study. This study highlighted the use of hydrological modeling for evaluation of widely 10 different satellite-based rainfall datasets. And as I mentioned in the previous slides, all the 10 datasets achieved good to excellent hydrological performance over the Blue Nile Basin. And in Tekesi Atbara Basin, all the datasets achieved good to excellent hydrological performance except Persian CDR, which achieved poor performance. And as you can see from the objectives of this study here, the second objective was to hydrologically identify which dataset product has the best performance along the three basins. And here you can see which datasets are the best for each basin. For the Blue Nile Basin, ERA 5 has the best performance and fit, followed by GBM and CHIRPS, respectively, for both daily and monthly time scales. And in the Dindi Basin, this is for Tekesi and Blue Nile. In the Dindi Basin, all datasets achieved poor hydrological performance except ERA 5, GBM, TAMSAT. The TAMSAT demonstrated the best performance, followed by ERA and GBM. Also, comparison of it is clear from the visualization of the results that the comparison of satellite-based simulated flow and observed flow over the three basins showed that in different cases the simulated flow sometimes overestimates as well as sometimes underestimates the flow. Also, the satellite rainfall data could be used from this research, and for this case study, satellite rainfall are highly recommended to be used as an alternative sources for the data, either for the terrain data or for the rainfall or potentially evapotranspiration data. In the study area as well as in engaged areas neighboring these basins. For the recommendations, it is highly recommended that NBI should conduct, or researchers, NBI, stakeholders, but decision makers, and so on, should conduct further and intensive research on validation of these satellite-based rainfall datasets to ensure the reliability and to enhance the figures of these satellite-based rainfall datasets. This validation can be done either using hydrological modeling or meteorological stations. For example, point-to-grid validation. MBI or countries should support and fund the establishment and expansion of hydrometric and meteorological networks in the Nile Basin to meet the international standards. When we talk about the international standards of meteorological stations, according to WMO, the recommended density of ground rainfall or meteorological station network in tropical regions is 1 gauge per 600 square kilometer for flat areas and 100 square kilometer for mountainous areas. I think NBI should support and fund this kind of investment to expand the existing networks to meet the international standards and so on. The last one is we have to invest more and more in developing guiding principles and practical solutions for transboundary water resources management, besides promoting and encouraging the bilateral cooperation in data sharing and coordination between different countries. I mean, countries that have cross-boundary or transboundary rivers. And I think this is the last one. Thank you for your attention. Thank you.
Thank you very much.
I hope I didn't talk too much.
It was interesting and nobody complained. It was very interesting. Thank you. And those two examples of Lake Tana and the sub-basins of Tekezi Adbara and Blue Nile is a good example of what Engineer Russell was introducing us in the morning in his keynote speech on how remote sensing techniques and approaches and methodologies can complement the Earth observation, so we strike the balance and have this optimal composition of an integrated system that is not data-based but information-based. And you introduced some very useful concepts like analytic modeling and hydrological analysis and water resources assessment through a combination of remote sensing and modeling. So this is pretty interesting and it will trigger a lot of questions. I would like to recognize my two good brothers, Dexius and Dita. But before we start the Q&A, we had one question for Mr. Fichoma. He is saying the presentation is fantastic. Can you share the link for the remotely sensed data and where can I get the raw data for Lake Victoria? This is from Peter. The second question I would leave for the moderator. It's a bit long, and it's about the rainfall runoff modeling and the use of historic data. So, Ato Fichoma, would you like to respond to Peter Wasawa?
Okay, thank you, Dr. Moshan. I will share the link on the chat. Yes, it is available for Lake Victoria. So I'll share the link there. Is the other question addressed to me?
No, that's quite okay. Didas, do we have any other questions?
Yeah, thank you, Dr. Moser, for the floor. We have another question addressed to Tishome. Someone is asking why rainfall runoff models based on hydrological data, historical data are affected by climate change factors and are not more realistic. He's asking how this dimension was not considered in the, by the presenter. Thank you.
This is from Kidani Tisfay.
Yeah.
But I think he elaborated more, Didas. He was like challenging the results of some climate modeling in the rivers and reservoirs and the weather conditions and tropic and dry regions and the storage and flood and upper reaches and availability of water and to avoid the hazards of floods and regulate the floods and rivers. So he was asking, do you have any comments regarding this? So I assume that Mr. Kidani is still talking to both presenters. So we give the floor to Dr. Muhammad and Ato Choma if they would like to comment about the accuracy of rainfall runoff modeling and the climate modeling and the dry and weather conditions. So if you have any comment regarding this question about the accuracy of the rainfall runoff models, we give the floor to Dr. Muhammad, then we go to Ato Choma again.
Okay, thank you for the question. Actually, as I mentioned, that the hydrological modeling has a lot of purposes and applications that can be used on it. The climate change is one of these applications that can be used, that can hydrological modeling be used there. In this study, we didn't try to address the climate change as the climate change itself in this in this kind of hydrological model application. In this study, we just try to evaluate the different satellite-based rainfall data sets to assess the water resources availability and management in these basins. But you are right, in the future, it is strongly recommended to assess the model to addressing the climate change, and also to address the sensitivity and uncertainty. This will maximize the benefits of the hydrological modeling and will increase the reliability and applicability of this hydrological model to be used for different uses and different purposes. Thank you for your question.
Thank you very much. Ato Fichoma, do you have anything to add?
No, I don't have that much to add. But in our study, we modeled the hydrology of Lake Tana in the past. So all the variability, everything is already captured in the data that we have used. So, of course, it is important to consider these climate change factors in hydrological modeling. And it will be very interesting to consider using remotely sensed data to analyze climate change factors and consider them in hydrologic modeling. But for us, we just use the past data, so everything is considered in the data that we have used.
Okay,
Thank you
very much. However, I would like to point out one fact, that since we started the Nile series in 2002, that changed now into the Nile Basin Development Forum, it's not to extensively discuss the topics and agree on a resolution or a common understanding or isn't a way forward. It is just to induct and introduce the topics to all of us. Then we will have the proceedings of the Nile Basin Development Forum 6. Then you will have the full list of contacts of each participant and presenter and panelist. So we can initiate even some groups on the social media or other means to have this kind of discussion live and to keep informing each other. So we'll have other extensive time to discuss furthermore. So don't get disappointed if your question is not fully answered at this platform, because within 2 hours, we cannot cover everything related to river basin monitoring and all the technologies and all the institutional aspects and considerations. So since Didas is a rapporteur and he has a question, I would love to give him the floor to ask a question to Engineer Russell Bowles. Didas, you had a question.
Yes, Dr. Moses, thank you for the floor. There is one question addressed to Engineer Russell, saying that why choosing the right technology, why existing national policies in riparian countries are not taken into consideration, since some countries are not willing to use satellite technology as data transmission option. I want from Lucy to comment on this, because we may have some cases in the context of Nile Basin regional hydrological monitoring system. Thank you.
So,
Yes.
Russell, can you give us the international dimension of this? It's not a discrepancies, but it is due consideration of national policies, limitations, and constraints when it comes to technologies. Please go ahead.
Yeah, it's really not a technology question, because the technology will allow you to, in this case, it's particularly focused on satellite communications. The technology will certainly allow you to do that. And I have no problem with respecting countries' decisions on their policies in what technologies they will allow for various reasons. And as you have pointed out, it is a consideration that guides the selection of the technology. But first, what you have to look at is basically presenting the technologies that are available, then running them through the screen that the national policies allow and don't allow for those particular technologies. And policies will vary over a period of time and change, be modernized, and be adjusted based on various circumstances in a country. So that has to be respected, and your point made is a good point. But it's not a technology limitation, it's a policy that screens and focuses on the use of certain technologies. Thank you. I hope that addresses your question, Tidas.
Thank you very much indeed, Engineer Bowles. Due to time limitations, we have now to go straight to the panel discussion. So I'm not sure whether we have Engineer Jackson, the Commissioner of the Ministry of Water and Environment Uganda, Dr. Kevin Wheeler, Engineer Benjamin went on a mission this morning and he cannot be with us. And again, our expert, Engineer Russell Bowles and Engineer Mark Woodbury. Is everybody here for the panel to start immediately?
Yes, I'm present here.
This is Mark, and I'm ready to go.
Thank you, Mark, as usual. Mark, Kevin, Russell, is Jackson around? Allow me to call him shortly to see whether he's able to join us. We need a Nile Tech member to be in this. We apologize. I think Engineer Jackson was called for something because his phone is off. So we need just to proceed. And we have 3 panelists, and we will have 1 or 2 questions each, but we will give the floor to every panelist to express his overall view. Then we will come back with questions from the floor if needed. But the whole idea of the panel is to talk about the whole context of how river basin monitoring is supporting, promoting, and really reinforcing infrastructural development within the Nile Basin. So it is well known to all of us that MBI supported the member states to jointly develop a portfolio that worth more than US 6-point-something billion during the last decades. Through the 2 channels, the multi-purpose, multi-sector investment opportunity analysis in both the Eastern Nile and the Equatorial Lake region. The identified investment projects are on different stage of preparation. Some of them are on the design phase, some of them are on the implementation, like Rusumo. Given the great potential of the Nile investment program to improve livelihood and lead to sustainable, enormous development within the basin. Can I start with Kevin? If Dr. Kevin, if you can talk to us, please, about how do you see the critical role of basin monitoring in enhancing transboundary basin planning, management, and development? And what are the international best practices regarding ambitious investment plans in terms of promoting infrastructure development within the transboundary context, meaning the cross-border river basins? Kevin, please, the floor is yours.
Yeah, well, thank you for the opportunity. And these are challenging questions, and it's an evolving field and discipline. Not only is the science evolving, but the institutional side on how to integrate this science is rapidly evolving as well. So whether there are best practices or not, I think is still to be seen. There's certainly some good examples and of how it's being integrated, how increased remote sensing is being integrated into transboundary contexts. But every situation is different. Every situation is certainly unique. I often work more on the water management side, and particularly on the Colorado River, where I work with U.S. and Mexico in the negotiations in that context. And still the remote sensing aspect is integrated into some of the forecasting that's provided by the United States. I do have some slides I can present on the Colorado River context if we're interested in that now, or I can present that another time. But what I would emphasize is there's a lot of potential, and I think some of the things that particularly Dr. Engineer Russell Bowles mentioned, it's not necessarily it's not a substitute for ground data, but it really emphasizes the fact of having a few good strategic stations that all countries can agree on, that allow the utilization of the remote sensing technologies. So providing a lot more information, but still needing those very strategic ground locations to be able to utilize that information. I would say remote sensing doesn't substitute the ground data, it simply augments the ground data in a lot of ways. So, but if we'd like to talk about the Colorado River context, I can present a little more on that whenever would be appropriate for
that. Thank you very much, Kevin. Given your extensive knowledge on the Colorado River Agreement and the process and how did you reach the agreement, we would like to listen to you if you have anything ready, or if you can talk to us directly about the Colorado River agreements and maybe the lessons learned, and how can we take from the achievements in terms of reaching consensus on this very important topic. So Dr. Kevin, the floor is yours if you want to introduce us to this topic, please.
Yeah, I'll just be happy. I prepared a few slides that might be helpful in putting some context. Are you looking at my slideshow right now? Okay.
Yes.
So just some very quick pieces. I thought about the questions here. How can the key questions for the session? How can basin monitoring systems combine with physical networks and other techniques for comprehensive monitoring? How can the field measurements and Earth observations adequately inform basin planning and management? Well, by themselves, I don't think they can, the Earth observations, but how can they jointly do that? So very quickly, just want to describe sort of the data sharing and monitoring setup between the United States and Mexico. and I'm not, I don't work for the governments there, so I'm not representing anything like that, but I was involved in the negotiations between the two countries. So a lot of that's administered by the International Boundary and Water Commission, or what we call the IBWC, which is formed with a Mexican section and a US section to be able to administer all matters related to the boundary and the sharing of water across the U.S.-Mexico boundary. And so there's two different rivers that the IBWC really are at. There's some smaller ones too, but two major rivers: the Colorado River as well as the Rio Grande, Rio Bravo River, called different in different countries. So they administer the water allocation as well as the monitoring of the flows in each of those. And my background is primarily in the Colorado River. So I'll just highlight or elucidate a little bit of the details here. So a lot of the information comes from the Colorado River Basin Forecast Center, where there's a vast network of gauges all across the portion of the United States. And as we can see in this previous map, a very small portion of the river actually is within Mexico. The vast majority of it is within the United States. So all of these different data points are available, and these are representing the real-time conditions. And all of this data is made publicly available in real time. It's a very key piece. So both users across the U.S. as well as Mexico can review all that.
Sorry for interrupting you.
Yes, sir.
Dr. Kevin, but
yes.
It seems like that you didn't share your presentation, because the only first slide that
it's just the presentation is not running. Is there a presentation or this is just Kevin?
Let me work on that again. Right.
This is just a cover page.
Okay, that's good. Good to hear that. How is this now? Dr. Mosen, can you see the cover page now? Changing?
Yes. But
we're seeing your presenter view.
You are using the presenter view. Just use the. Yes, that's better. Thank you.
Okay. Key questions right now?
Yes.
Okay, excellent. Thank you for pointing that out. Okay, so again, the International Boundary and Water Commission, please feel free to stop me if it freezes up or any problems at all again. So International Boundary and Water Commission. Here are the two rivers that the IBWC, the two major rivers that they manage the relationships between. And again, Colorado River here. On this slide, you can see the vast network of gauges within the U.S. Where that information is shared via the Colorado Basin River Forecast Center, and that's all provided real time. And again, all that data is made publicly available real time as well. So anybody could log on to this website, and we see different flood stages. We can see different snow conditions, forecasts, etc. Daily precipitation, monthly precipitation. A vast amount of information is shared. So a lot of the satellite imagery, a lot of these are products of models where the satellite imagery is, or the satellite data is integrated. And again, a whole time series of different forecasts, or a whole network of different forecasts. We're currently indicating most of them are in red. So everybody across the basin can really understand kind of what the current status is of the basin. So really quickly, how the U.S. and Mexico manage their relationship in terms of the U.S. making water deliveries to Mexico. In general, there's always an annual plan where Mexico presents a schedule of delivery requests to the IBWC, and the Mexico every week submits a schedule down by the day to decide how much water would be, or to request the amount of water. And then the US makes releases from the storage reservoirs to fulfill those schedules. And then the deliveries to Mexico are jointly monitored by the IBWC. Members from both countries are participants in the IBWC to ensure treaty compliance with the allotments and schedules. So even ingrained in the treaty in 1944, long before any of this technology existed, satellite technology, was very clear that the commission would construct, operate, maintain all necessary gauging stations and other measuring devices to keep a complete record of the waters delivered to Mexico and the flows of the river. Now we can imagine what the treaty might say in the age of satellites. Probably not much different, actually, but it would have some commitment to maintaining record. The IBWC, they jointly operate 6 gauging stations on the Colorado River. The US operates an additional 5 stations for the treaty purposes. Then the data is jointly collected and compiled and reviewed by the IBWC. And then every year their reports are published in both English and Spanish to make sure that's all publicly available. And it's also worth mentioning the notion of salinity, because that is such a major issue to maintain the water quality, that the waters of Mexico are not too saline. And so there's a concerted effort to make sure that the salinity, there's compliance, and it's being monitored both by the US and Mexico, monitored regularly, and monitored by both the US and Mexico, and then reconciled and jointly compared by the IBWC. So just a lot of deep collaboration to make these things happen. So that's a little bit of a side piece. And here's the river coming across the border, and where the major diversions are to the US and Mexico, both flows and salinity are really monitored just upstream of both of the diversions. So they can be shared interactively. So where does the technology sit in for or used for this? Well, in general, when we have the 2 countries or 2 different countries, any 2, country 1, country 2, generally have some layout of the raw data being produced, and that gets transferred to some sort of cleaned up data. And that raw data is exchanged openly between the countries, as well as the clean data exchanged between the countries as well. And then that all gets fed to Joint Scientific Commission, which in this case is the IBWC, to be able to compare, process the data, verify the calculations and methods, and then compare with satellite imagery, or compare with some of the remotely sensed data, to be able to validate and expand upon the measurements and fill holes and gaps, and thereby producing regular reports, and most importantly, a set of the naturalized hydrologic conditions, both historical as well as allow the modeling to provide forecasts of what the conditions might be projected to be. And from there, that allows joint modeling, or joint commission to do modeling, or the individual countries doing their own modeling, but based on the same sound scientific principles or sound scientific input information from either country to be able to do their own individual analyses. So that Joint Science Commission really plays the central role to generate the hydrologic data set, and that utilizes both the ground data as well as the remotely collected data as well. So overall, some of the big scientific questions: what historical hydrologic conditions would exist, and how much water can be expected to flow in above all of the infrastructure? And then the typical safety questions: how much water is in the reservoirs, how much would be released from the reservoirs, some of the more challenging political questions, how much water should each country be able to deplete in the future? The satellite, they can help out with a lot of these questions, such as how much water can be expected above all the dams and how much water is or will be stored in the reservoirs during a current year. But of course, it can't answer a lot of the other challenging questions. So science and technology will help this process, but of course, it's not a substitute for the political will required to be able to manage the river. So that's all I really had for the U.S.-Mexico and just sort of an overall view kind of the information sharing process. But it's certainly, and even though there's really important technology that's increasing within the U.S. and being utilized, it's still a combination of the ground technology, the more advanced remotely sensed technology, but still a commitment on both sides to be able to continue sharing and updating this data, especially as the technology keeps on increasing exponentially. A lot of those fundamentals are ingrained within the agreements that both sides are committed to being able to develop and maintain records of what the flows and the salinity at this point would be. That's all I have right now, but I'd be happy to expand on any of that.
Thank you very much indeed, Dr. Kevin. This is very interesting to see that confidence building is materialized into agreement and then shared monitoring network and exchanging information and having the institution set up for compliance monitoring and improvement, and how the science can support the political will in order to achieve this kind of joint management framework that is stable, up and running, with as smooth as we can see. We will get back to you with many questions, but now I would like to invite Engineer Mark Woodbury again to give us some insight of a recap from everything that was discussed yesterday and today, and some thoughts that can stimulate our thinking to get out of the box and to propose some innovative ideas for promoting basin cooperation within the Nile. Mark, the floor is yours.
Mohsen. So I want to invite us, you know, many of us are engineers, we think in these sort of practical ways, but we sometimes don't think about the human aspect of what motivates people to act and to improve. And so I wanted to make reference to what I will start by referring to as a mountain of capital, a mountain of resources that exist to help us in addressing these problems and improving the water resources information value chain that we discussed yesterday. And I wholly endorse Russell's presentation earlier today, and he and I have collaborated on these things, but just reminding us that we really want to move from data and information to really positive socioeconomic impacts. That's our goal. In a book titled The Mystery of Capital, author Hernando de Soto identifies that the informal capital, the non-registered real estate and other resources in developing economies represent easily between 10 and 150 times the all past foreign direct investment. So if we think about all of the resources that have been donated or invested by foreign countries in a particular developing area, what he's saying is the local economy has 150 times that much wealth in itself. And that's just tangible assets and real estate. If we think about the real resource that exists in these economies, it's the human capital, the people whose energies are waiting to be deployed and directed in valuable endeavors. And we don't really get to decide how the individuals in an economy deploy their own capital, but we want to figure out in our little piece how we can harness the potential of the people that are there to improve this value chain. And the most fundamental ingredient is in them deploying their capital, in acting to improve, is the expectation that they will be permitted to reap what they sow, to keep what they earn, and to permanently retain the value of any improvements they make in the environment around them. That motivates people to act and to invest far more than we could compel them to do. And so let's think about that in terms of the water resources information value chain. The idea of everybody in the economy investing in things may seem a little bit remote when we're talking just about water resources management, which is more of a collective government function than private activity, but the same motivations that apply to individuals in the economy also apply to each of the individual actors in the data and information value chain. So the access, we want to access the value of human capital represented by those actors by fostering an environment that increases their individual motivation to invest. And when I talk about them, I'm talking to each of us, because we are those actors. We use a systems approach to think about the fact that there are multiple pieces and we need to strengthen the weak links across the entire system to achieve sustainable progress. And for lasting impact, we need each person along the value chain to be incentivized and empowered to act in the best interests of their stakeholders. So let's talk about what that might mean. We presented yesterday this slide that suggests that sustainable value chain includes the sustainable monitoring programs, information products and services, dissemination and outreach, knowledgeable users, real impact, and then a return investment based on the beneficial impact in keeping that information flow going. So let's look at some key ways of harnessing individual human capital to make that happen. Obviously, stakeholder engagement and consultation is a critical component. And those stakeholders would include the hydromet observers and technicians, hydrologic services staff, water resources managers and planners, engineers and practitioners in the private sector, policy officials and legislative staff, and government and corporate officials who are in ancillary industries like hydropower and agriculture irrigation. We empower actors through the subsidiarity principle, which is that actions are governed at the lowest level appropriate for the decision at hand. We give as much autonomy as we can to each of these actors. And that's clearly a policy change and a policy item to consider. We increase the accessibility of river basin monitoring information. There's a lot of effort and investment that's been placed into obtaining it, and the best benefit we can get out of it comes from making it accessible. We develop users. We discussed that yesterday. There's a slide that was in my presentation that can be referenced of ways of developing users. And then we establish policy that reference the information so that information is required to comply with policy. That means that policymakers and government officials have a need for the information because it's a part of the requirement for the functions they perform. And then we leverage technology and infrastructure investment. And I wanted to point out that I put the technology last because it exists and we can access it, but it's not helpful if we haven't first figured out how to engage the institutional aspects to make things flow. Yesterday, we talked about this graphic of sustainability factors, and I want to show how this relates to that list previously. Client services is what motivates the production of information. Normally, I wake up at 5 o'clock or 6 o'clock in the morning. And if you tried to wake me up at 2 a.m., you would have a hard time getting me out of bed. But my alarm went off this morning at 2 a.m., and I knew that I had to talk to you today, and that gave me motivation to wake up and get dressed and be ready. There's something about having a demand for information that motivates us to act and do something useful rather than just think, well, nobody's looking at the information I'm producing. Why should I bother? The policy dependency was the motivation for the item in the previous list of establishing policies that reference information. Institutional capacity, that's where we're empowering actors. And technology is the piece associated eventually with leveraging the technology so that we can efficiently feed this value chain to operate and maintain our system. So let's, in wrapping up, I'd like to mention a tale of two forecast systems. I implemented a forecast system over a 10-year period in a country in Latin America with significant investment. But because of the organizational structure, all of the information went to feed one public official in his decision-making. And it didn't have significant users and application beyond that one person. And that, despite the investment, that system did not flourish. We had a 2-year project to implement a forecast system with far fewer resources in a different Latin American country. And in that country, which was smaller and with fewer resources, they identified the forecast system as having great value, and they made linkages with the public television station and with media outlets, and they implemented the forecasting results in the policies of the country. And that system continues to operate today with a forecast center and multiple monitors dealing with meteorology and hydrology. They have regular briefings. They have places for the media to come. This is an incredible success system because they engaged with making the products available and useful so that there became this regular demand for data, and that process fed on itself. We come to the conclusion where I wanted to show some examples, and I think that our time is up, but I just wanted to share one example and reference a few others of how people will use information in ways that we never imagined. I found a product that shows rainfall amounts anywhere in the United States, and I can choose between 1 hour in the past up to 72 hours of past accumulated rainfall. I use this map on a regular basis to plan my activities when I like to go mountain biking, yet I need to monitor trail conditions to see if it's too muddy to go there. I live in North Carolina where it hasn't been raining lately, but this map makes it possible for me to find locations where there has only been 3/100th of an inch of rainfall versus places where there has been up to 1.5 inches of rainfall. And this becomes a very useful product for me making decisions or for officials who manage the access of those trails. I wanted to point out that the United States Geological Survey makes data from 6,000 or more stream gauges available in real time on its website. And that can be seen when you click on one of those stations. You can see the active data right up until the current hour. Kevin mentioned the Lower Colorado River, and here's an example of a diagram that very quickly conveys to the public what is the current status of the reservoirs, how full are they. Finally, there's a product available. It's a provisional demonstration product at the moment, but this shows in different colors, green, yellow, red, the navigability of rivers in the Bahr el Sobat Basin in Sudan and Ethiopia. It's a marvelous thing to make something available to, I don't know how many of the people there actually have access to internet to be able to see a product like this, but conceptually, this is a very practical product to allow somebody to determine if there's the potential for navigating and moving goods up and down the river. Wilson, that's all I had, and wanted to thank you for the opportunity yet again to present the information and think about the benefits that can be realized when we activate the human capital that exists all around us. Thank you.
Thank you, Mark. Can we give the floor for Russell if he wants to add something to the other two panelists? But we will have one question each to wrap up the panel. But let us get the floor to Russell in case he wants to add something to our insight and knowledge. Russell.
Yes, thanks, Dr. Mosen. And I certainly enjoyed Kevin and Mark's presentation. Kevin's resonates very well with me. I've been involved in Canada-US transboundary waters for almost 30 years under the International Joint Commission, which is actually established under the 1909 Boundary Waters Treaty between Canada and US. And everything that he's mentioned as far as the principles of openness, sharing, trust, joint development are exactly the same along that border. It involves likely 15 to 16 various river basin boards that are actually migrating from just looking at stream flow information to now being much more concerned about water quality in the last 20 years as part of that arrangement. But it's in the last 5 or so years, it's looking at more integrated watershed issues and aquatic ecosystem health type of transboundary issues and how to resolve them. So I'm really interested to hear about the Mexico-US relationships as well. And it is about building trust. It is about building respect. It is about openness and sharing. I'd like to pick up on Mark's presentation, and it's to comment on the question of whether the regional basin monitoring program will enhance investments in the Nile Basin. And I have a very simple perspective on it, and it picks up on Mark's comment about capital and motivation. And when you think of investments, if you were investing, what is your what is your biggest concern when you're thinking of an investment, and perhaps what motivates you? The concern is the uncertainty that's associated with that investment. And that uncertainty leads to a risk concern. And if you look at it from a river basin perspective, that risk is multidimensional. It's not only the economic risk that you may be faced, but it's also the environmental risk dimension, the social dimension of that risk. And we also need to consider the cultural and spiritual nature of that risk. So if I'm going to invest, what I want to do is minimize my uncertainty, which minimizes the risk that I take. And so how do you achieve that? Well, you achieve that through all the things we've been talking about, is knowledge, information, which is built on data and observations, whether they be ground-based or satellite, space-based type of observations and interpretation of that. And that all leads to better understanding, which I think is directly linked to trust and respect within a transboundary type of context. So that's what I think the regional basin monitoring program is critical to that dimension of reducing the uncertainty, to address the risk, and to build those relationships. And so I'd like to leave it there, Mohsen, at this time. Thank you very much for the opportunity to comment.
So, leaders, do we have any direct questions, or we ask the panelists the difficult questions from NBI?
We don't have question from Q&A feature. Just proceed with.
Thank you. Then, before wrap up, we had some kind of very interesting and very insightful experience from transboundary rivers in the United States, Canada, Mexico, in the West. So I tend to ask the participants, given that we had assessment of the river basin monitoring within the Nile since 2009 up to now, it's almost more than 1 decade. The conclusion of the assessment that was done under the Water Resource Planning and Management Project within the NBI umbrella was that our river basin monitoring is far from adequate. And they have spelled out all the gaps and weaknesses. Based on your experience, I will ask Kevin, Mark, and Russell to highlight one of the most impediment challenging that is fundamentally drawing our attention as the challenge that we have within the Nile Basin to achieve the international standards in terms of technologies, infrastructure, institutional capacity, and most importantly, the limitation of data availability and data exchange. Although we have within the NBI the interim procedure for data sharing, it is still not fully functioning. So can each of the respective panelists highlight just one lesson learned or one kind of a challenge that we can work on, we focus, we emphasize to underscore the ultimate objective of enhancing of Nile Basin monitoring for better cooperative water resource management and development, and hence improved livelihood basin-wide. We start with Kevin.
Okay. I think I've been working on the Nile for almost 10 years now. And I agree, there's obviously been a lot of investment put into the platforms and the data acquisition and honestly, nothing seems to have real, from an outsider perspective, data is no more accessible now than it was 10 years ago. Even though there may be more data collected, it's still very difficult to get. I think beyond obviously the political will question, which I think is the number one factor. If you really want to cooperate, you really need to share information. That's a given. But I think one of the other challenges I think for NBI is to identify, well, what is publicly available and what is not publicly available information. Because oftentimes I think there's a lot of information that could be shared, that could be exchanged, but nobody really knows exactly what is available. So I think if I were to say one challenge of that, certainly there's always caution about the most recent data, current conditions, that type of thing. But we're also talking about historical data that goes over 100 years, and that information is still difficult to acquire. And I think that one of the really big challenges is to understand that there is a lot of information out there. And there's a lot of sensitivity around, particularly around most recent information, but to really make a paradigm shift from producing results to producing information, because the information is really where the cooperation can happen, because everybody's going to analyze that information in a different way. And sharing the methods, not necessarily just the reports in the end. So I think that so identifying what is publicly available versus what is not publicly available, and focus on providing information and not on providing reports, I think to me are the two big challenges that I think could help the basin move forward.
Thank you very much, Kevin. Mark?
Yes. Mohsen, I feel like I've spoken a lot over the last 2 days, and so I don't have a lot more to add, other than just the idea that it's not significantly different than what Kevin said, that creating demand for data by finding ways to make it accessible and developing a user base, and seeing information as a public resource like water itself that can come to its own life in finding ways to improve lives and livelihoods would be the biggest challenge to overcome. It's the challenge to overcome being the attitudes toward data, to change them from being something that we hold closely as some sort of asset that we want to get benefit from, as opposed to a product to make available so that it can create value in society. That's the challenge.
Thank you, Mark. Russell, I will change the question. You have extensive knowledge in international river basins around the world. And universally, every certain river basin authority is passing through the evolutionary phases of establishment, reinforcement, institutional capacity, then delivering, then providing services, then the maturity phase. In the Nile Basin, based on your experience, maybe for the last decade and your interaction with multi-stakeholders and different parties involved, based on your understanding of the limitations, the constraints, the fears and concerns, do we have a hope that one day in the near future, we will have something like what Mark has been presenting as samples, where people can scroll the internet and browse some hydrological data and hydrological analysis and some forecasts and some historical data and updated real-time data and information that everybody get access to. Maybe different specialists and public and high-level consolidated information for decision makers. We can have this hierarchy, but do we have a hope that this can be achieved in the foreseeable future, and what it takes to achieve that?
Excellent question. I just think about some of the presentations that we've heard today from the two individuals that were using remote sense products to look at basin perspectives, and they were not country specific, they were basin perspectives. So I really think that part of the technology starts to lay a foundation for thinking different about what you actually control in the sense of information. Is the Internet of Things, the space-based technologies, all of that opens up a different arena that countries have to work in. And I think it will facilitate the sharing and the better understanding of a regional perspective because of that technology. And I also think, I'm very hopeful about the Nile Basin. I really think the investment that's being made in the regional basin monitoring program at the current time by EU is really, really going to be important. It's going to be a really good demonstration project to support this. But I think we need to be thinking about it not from trying to share data, but trying to figure out how we produce information products, either at a bilateral, multilateral, or regional basis, and focus more on the products of information that add value than having the debate around the actual raw data, what's available, or the specific data points. So I think it really needs to focus on that. With this perspective that I can derive information products by satellite-based analysis and modeling, that gives me some representation of what's happening in the basin. The other perspective I think that's important to look at, and Mark has mentioned this on a number of occasions, is there's always, from a basin, a multi-country basin perspective, is the thinking of upstream, downstream type of perspective. And I would offer that every country is a downstream country within the basin, from not only the context of water resources, but the social economic makeup of the region, the impacts of climate change and climate variability is every country that's in the Nile Basin is actually a downstream country. And we need to be thinking about it from that perspective. So I think as attitudes shift and as people see the benefits of information, I'm very hopeful that the Nile Basin countries will emerge as a major block to demonstrate what can be achieved through cooperation, trust, and respect. Thank you, Mosen.
Thank you very much, Pete. Before we thank again the panel members, I would like to give the floor to Didas and Dexius. So, Didas, do you have anything to add?
Thank you, Dr. Mosen, for the floor. Just to add on this limitation and constraint in terms of cooperation around this Nile Basin regional hydrological monitoring system, we need from riparian countries effective commitment and the flexibility in any data sharing, even if they have their own policies. I think there should be a kind of flexibility in terms of data sharing. Thank you. This is just what I want to add.
Thank you very much for underscoring this vital point. Autodexius, do you have anything to add or a wrap-up note or anything?
Yes, thank you, Mohsen. Thank you, Mohsen. I will have some points as a wrap-up and key messages. May I present that one? So, okay, hope you are seeing my screen.
Yes.
Okay. Well, a number of points have been raised in this important webinar. I tried to catch some of the key pointers and I present that. But I'd like to remind you that the well-organized wrap-up and key messages will be prepared and sent to the organizers for the record. This is just for us to take it on. So in the first very important presentation about this satellite-based information, it is the state-of-the-art technologies, application of these technologies in river basin management has been given. And one of the important messages was that through proper deployment of the technologies, it supports us, this technology supports the basin-wide planning and sound development. Yeah, proper deployment is required. And of course, it gives also provides additional data, services, product services, and of course, with value-added information. And it has a great benefit, and to achieve this benefit, we should think it as, this satellite-based information or remote sensing, whatever, as system of systems, data, some of systems generating data and information services. And this satellite-based technology have different monitoring technologies. Some use satellite-based satellite images or satellite technologies are there, which are geostationary and polar orbiting too. From the aircraft, from the ship, and as well as from the satellite ground station, a number of monitoring technologies are there. And the science or the technology is really improving every time, and more and more technologies are now coming to practice. And it has also good on this strengthening of the information value chain, which has also been presented in detail yesterday. The value chain is very important, and that is starting from the observation to the given to service delivery, and of course to the action or to the sustainable development. So in general, this just a repetition, sorry. And since a number of technologies are available now, there must be a way to choose the right technology for the right purpose that is fit for the purpose. We could have a number of, we'll have, when we are using the satellites, the data, we have a purpose. So we have to choose which data sets are to be used for our purposes, which fits our purposes. Its reliability, accuracy, its efficiency, its cost effectiveness could be a factor, of course, to choose the right technology. Nowadays, it has been said that since smart sensors are there, which require minimal power and calibration need, because as for river basin management, especially in the Nile Basin, the availability of power is limited. So with minimum power, the sensors could sense the data and log the data for a longer period. Of course, now environment is very have to consider in every aspect. So it should have minimum environmental parameters of this, because this technology could bring in maybe some hazardous chemicals or whatever to the environment. So it should have minimum footprint, environmental footprint. It should have also, of course, robustness to its data communication systems, its robustness and reliability, of course, all is related to the cost also. And of course, it should fit with Wmo Standards and Guidelines. Here, the message is that given was that the price is directly correlated to service life of technology. Yes, it doesn't mean, the higher the price might not be the best one, but there is a correlation. I think that's what the message wants, the presenter wants us to say. The other challenge is big data challenge. This for this satellite-based data are generates huge volumes of data, and to store, to analyze such data might be a challenge. And for that, we did really have to prepare to develop a very good data management system and apply a very good analytical tools, to store, analyze, and generate information of these huge volumes of data. So we have to prepare, one has to prepare for such challenges. And of course, interface challenges need some approach, or interface challenges also very important. The other thing is, when we are going to use these technologies, initial changes really required, because we are not going to store data generating from this kind of technology. So the initial change must think of it, that is moving from data-focused organization to a responsive information and value-added service organization. This is a very important message. One has, of course, to rethink that, focus on data management, information generation, in the Nile Basin, the rethink investment. We have to focus on the data management and information generation, enhance observation products, of course, in addition to the ground observation, and focus on few well-performing ground stations. This is also a very good point to rethink on how to invest in the Nile Basin. The number of ground observation, which we in the basin used to collect the data, doesn't mean that we have a huge number of stations have a very good quality of data, but the quality is very important. And maintaining your very few grounding station with a very good data collection program and monitoring program, and then this complement this with the ground-based data. That must be a good point to think of customers. And there is also a message: state-of-the-art technologies properly deployed will deepen Nile Basin cooperation and will advance informal basin-wide planning and sound development. And the other thing is, the application of this remote satellite-based data have been also presented for the case of Lake Tana. The application of this remote sensing data for estimation of lake water level and inflows of engaged catchments to the lakes have been presented. And it was a very good presentation, and it gives a good example how we are going to use such observation, global satellite-based data in estimating large lakes or rivers level and inflows. It was a very good, and you have the result has been presented. It is very well accepted results, and it was very good, and it was recommended to apply such kind of exercises in other basins and improve the results. And the other one is also a case of the application in the case of Atbara, Blue Nile and Tender in estimating the river flows. And based on this 10 satellites-based rainfall data and PET data sets, calibration and validation have been done on the 3 rivers, and in general, the total result shows that application of this use of the rainfall and base data, satellite-based data, really could give a very good estimation of river flows, and especially when there is lack of data sharing, among the countries. Application of such systems are really very good, and it's recommended. And also, of course, it was recommended to NBDF to undertake such exercises in other basins, and of course, support the use of satellite in other by countries or other basins, and supporting or undertaking such research. I think this is my last screen. Satellite-based data are not a substitute. This is one of the message. This satellite-based data are not a substitute for the ground-based data, but enhance the use of the ground monitor data, because whatever we are the data that are generated from satellite based should need to be calibrated or verified. There must be data truthing exercises to undertake or to apply such a basis, such as satellite-based data. So they are not a substitute, but enhance greatly the use of the data and give better information products. In addressing the webinar questions which we have about how the Basin monitoring system can use or combine physical networks, and how field measurements and observation are adequately for basin planning and so on. To answer such a question, the case of a Colorado River Basin cooperation was presented in detail, and in short, this the satellite-based information really help us to answer a number of questions, and raised, and cooperations among the two countries, especially the US and Mexico. Of course, all questions could not be answered from the satellite-based questions. Scientific questions can be answered, or can be really the satellite information can help to answer scientific questions, like how much water is expected this season in a year or so, in a year or is the coming season or whatever, how much water will be stored, and so on. Such information can be answered. I mean, the satellite-based information can really help to answer in a more accurate way, than the ground-based information. Of course, complements to the ground-based information. But of course, the political questions, there is no useful to answer such questions. So the point is, science and technology will help, but it is not a substitute for a political will. That's for satellite issue. I think that's what I am. As I said, we will come with our team. The RMA team will compile the wrap-up and key messages, and that's what I have. I have Dr. Musan. Thank you.
Thank you, Dexius. And we are now remaining with a big thank you to the panelists. And thank you very much for the presenters of the paper. And thank you for the participants who would like to appreciate the dedication, the time, the valuable input, and this kind of interaction that we should maintain for the livelihood and good well-being of the Nile Basin citizens. We hope to see you very soon. I would like to thank everybody who participated in this session, all the participants, Dr. Nicholas Azza, Patrick, Pamela, everybody who is supporting this. And we look forward to meeting you very soon. The dialogue has started, but it has never ended. We will be available for further discussion, and we will share with you the proceedings of this webinar with yesterday's and the other subject matter webinars. Long live River Nile, and big clap to Basin Cooperation. Thank you very much indeed. Have a good day.